Good afternoon, and welcome to the Database Administration Virtual Chapter Lecture for this afternoon. Our topic today is Replication Technologies, and we have Hillary Cutter, and my name is Julie Bloomquist. I'm the moderator today, and we are being sponsored by Dell Software. Dell Software allows us to afford the raffle for attendance prize at the end of the meeting. We have some upcoming SQL Saturdays in both North America and internationally. SQL Saturday is a one-day mini conference. Usually the only costs involved are those for your lunch, and they ask that at the registration, so if you don't show, the organization doesn't have to pay or lose money. If you're planning to attend the past SQL Summit, it's 2015. It's currently $17.95 until July 12th. And if you use the VC15 FPS6, you can save $150 off the registration. If you do use our discount code, we're going to receive a free pass for every 10 registrants. So these will be raffled off over the summer. There's the 24 hours of pass, which is coming up. It's again free online training, and it's 24 hours of lectures. So keep an eye out for that. It's 24hoursofpass.com. Whatever your passion is, there is a virtual chapter. There's a huge list of them. Just go out to your PASS membership, and you could associate your PASS login with any of the virtual chapters. You'll then be getting emails about the meeting announcements and be able to sign up to get the information. If you're interested in volunteering with PASS, there's quite a few opportunities. They also give an Outstanding Volunteer Award of the month, and the Passion Award is announced at the PASS Summit. Here's again the LinkedIn and the login and everything for PASS. And I'm going to pass this off to Hillary. He's a SQL Server MVP with 20 years as an IT veteran who's answered over 20,000 questions on forums. Just some of, I'm sure more than some of them were correct. He's worked for some of the largest and challenging SQL Server typologies in the world, and he's been MVP for 14 years. He's worked with some of the more complex replication deployments in the world. So Hillary, I'm going to change you over to be the presenter. There you go.
Great, thank you, Julie. Okay, can you ever see my screen?
Yes.
Okay, great. Okay, yeah, thanks for the introduction, Julie. So today we're talking about SQL Server replication, and we're basically talking about the native replication components. And SQL Server replication is what they consider to be a mature technology, and what they mean by mature is that there's basically no new development that I'm aware of going on in the SQL Server replication world. So this is who I am, and Julie's already filled you in with the dirty bits. Here are some of my clients. So what I want to talk today about is some of the replication types, performance tuning, troubleshooting, and monitoring. Now, what I'll be doing is I'll be doing a demo of some of the more common replication types, and I'll be presenting what I think is some of the more unusual aspects of them. Before we start talking about replication, we should start talking about the terms. We have, in the replication world, we have something called a publisher, distributor, subscriber, gateway, and article. These metaphors come from the world of publishing. So publisher is the source of your data, the source of the changes. Distributor is where the data is stored and then distributed to subscribers. The subscribers is where the data ends up. For some of the replication types, replication or data changes can flow two ways. It can flow from the publisher down to the destination databases, the subscribers, or they can flow from the subscriber to the publisher. For most replication types, the publisher is the central point of origin or the clearinghouse, where if you have two directional replication changes come from the subscriber up to the publisher, and then changes originally on the publisher going out to the subscribers, that publisher forms what we call a clearinghouse. So the publisher decides where does the data go. There's another replication type called peer-to-peer. With the main replication types, if the publisher goes offline, data will stay in the subscriber. For peer-to-peer, we have a mesh topology. So one publisher can drop off and the other subscribers can talk to each other and synchronize with each other. And then when the main publisher comes back online, the subscribers can talk to that publisher and synchronize their data. Gateway. Gateway is becoming a little obsolete right now. Gateway was used with Oracle Publishing. With Oracle Publishing, we could publish from an Oracle server. Changes originally on the Oracle server would go down to SQL Server, and then they'd be distributed to other SQL Server subscribers. So the main destination SQL Server database is the gateway, because data can go from that gateway SQL Server to other subscribers. In replication, the smallest unit of change capture is what we call the article level. So we can publish an article, which can be a table, a stored procedure execution, a stored procedure, a view, a function, and an index view. Replication types, again, borrowing from the metaphor of the publishing world, a snapshot. A snapshot, basically, you should consider a point-in-time image of your data. And whenever you run the snapshot will capture the state of your database at that point in time and then send it down to the subscribers. It won't capture subsequent changes which are occurring on your publisher. If you want to have any real-time or near real-time replication, what you would need to do is you need to use transactional replication. When you think about transactional replication, you need to think in terms of transactions. A transaction which occurs on the publisher is replicated as a transaction to the subscriber. That means if I affect, with a single update statement or a single insert statement, if I affect 1,000 rows, those 1,000 changes will be captured and replayed on the subscriber as an 1,000-row unit. If, for whatever reason, they can't be applied as an 1,000-row unit, the agent will fail until you fix that, because it guarantees that a transaction occurring on the publisher will also occur on the subscriber. And this way you can guarantee that your publisher and your subscriber, your source database or your destination database, are identical. And by identical, I mean they're identical within a couple of seconds, perhaps. Replication latency, which is the difference between your publisher and your subscriber, your source server and your destination server. So we call that latency, and it's the difference in time between the two. Replication can offer typically 1 to 2 seconds of latency, but this can change dramatically depending on what is going on your publisher. So it can be minutes, it can be several seconds, several minutes. If you're doing a really large batch update, it can take maybe an hour for that change, that large change, large batch change or large batch process to be distributed to your subscribers. Transactional replication with updated role subscribers is deprecated. It's still in SQL Server 2012. And what that allows you to do is if a change occurs on a subscriber, this change can be replicated back to your publisher. And this was designed for a sweet spot where the majority of your changes occurred on your publisher and only a few changes occurred on your subscriber. We have bidirectional transactional replication, and this allows you to do load balancing. So a change occurring on one node in a bidirectional transactional replication topology could go to a second node. Changes on the second node can go to the first node. The latency can be within several seconds. Peer-to-peer is an extension on bidirectional transactional replication. With peer-to-peer, you can have multiple nodes all replicating to each other. With bidirectional transactional replication, the sweet spot is for two nodes replicating to each other. If you go beyond two nodes, the amount of writing, redundant writing, starts to grow exponentially. With peer-to-peer, you can scale to maybe 10 nodes. And it really depends on available bandwidth and your workload as to how high you can scale. Merge replication is an out-of-the-box bidirectional replication topology, and it's designed for basically for where you have a store and you have multiple branches. So it's basically that's where it's designed for, and it can scale to many thousands of clients. I've worked on topologies with around 4,000 subscribers. Synchronization services was a option which was included in the install package, install the setup program of SQL Server 2008, and this was where Microsoft encapsulated the merge engine into a class, and it allowed developers to use that engine in the class, in the .NET class, to roll their own replication solutions. It's no longer included in the setup programs, and there are support issues with that. Next slide. Okay. So replication use cases, the number one use case for replication is when you want to offload reporting. If you have 1,000 users banging away at your main OLTP server and they're doing all sorts of reporting on where you're trying to do a large number of writes, there'll be quite a bit of contention. So what most people will do in a scenario like this is they will direct their reporting workload to a different server, and they'll replicate the data between the two. And this works really well when you don't have very tight consistency requirements. So you can tolerate being a minute, maybe 10 seconds out of date from your source server. It can also be used to move data closer to the consumer. So if you're doing a lot of link server calls, you may want to take, instead of using the link server, you want to take the data that you're querying in that link server and move it to the subscriber and query it there. You also may need to create islands of data that users can access. For example, about 10 years ago, one of the number one consumers of merge replication was the multiple listing services for some states. And what would happen is people would come in the morning, or realtors would come in the morning, they would synchronize their devices with their Palm device, or their Windows devices, the Windows CE devices, with a blob of data which would contain all the listings in their area for that day, and then they go out with their customers throughout the day and show them homes on their handheld devices. Since most phones today are able to access large amounts of data over the internet, they don't really need to do this anymore. But this was one example of creating an island of data on their handheld device, which they could take for the day and work for the entire day off that blob of data. It's also useful for replicating to SQL C or the SQL Compact Edition. You can use it for load balancing, scale-out, and scale-out reads. You can also use it to a lesser degree for high availability or DR. And I want to talk about this one. So for load balancing and scale-out reads, peer-to-peer is a better fit. You can use bidirectional replication. Most people today are using availability groups. Availability groups require that you use the Enterprise Edition, and there are some exciting changes coming with SQL 2016, which may make this more affordable. With availability groups, you have to watch out for latencies. If you're doing large logged operations, you may find that the latency between your primary and your secondary replicas can be significant and can even slow down activity occurring on your primary. Indexes on your primary for an availability group, you may want very lean indexes to increase your OLTP workload, whereas on your read-only replicas, you may be doing a lot of reporting, you may want large indexing or large indexes to handle that reporting workload, and you can't really do that right now with availability groups. So replication may still be a good fit for load balancing and scale reads. And you have to be careful if a client is going against one node, and then when he comes back, will he go to the same node? If he goes to the same node, he may not. If he goes to a different node, he may not get the same amount of data, which is on the original node. If you have data distribution problems, if there's latency between the two nodes. High availability and DR replication is not a good fit for that because it doesn't do client redirection. For small workloads, it may work, and for some of my clients, I have set them up and they're very happy with it. All right, so what's new in 2012 and 2014? So replication plays nicely with always on if you're using a remote distributor. There's performance improvements, bug fixes, there's new extended events, we'll cover those in a moment. Sync services is no longer part of the install. You have the ability to replicate to the cloud, and if you're interested in that, you can look at that video. All right, replication extended events, I'm just listening here. I haven't really been able to figure out how to use these, but they are there. I assume they're for Microsoft internal debugging purposes. So let's look at the replication types. The first replication type we'll look at is snapshot replication. Again, a point-in-time image of data which is sent to your subscriber. It's the best fit when the majority of your data changes at one time. For example, if you're doing quarterly catalogs, if you're updating price lists, maybe every week or something like that, you may want to send a new snapshot down to your subscribers. You have to think carefully about using the snapshot replication because basically what you're doing is you're sending the slug of data from your publisher to your subscriber. If you're over a low bandwidth line, you don't want to send large volumes of data there continuously. So it works best if you're sending there occasionally. If the data changes every day, you want to use something like Transaxle Replication for that because it has lower network bandwidth requirements. It's a good case when you have tables which don't have primary keys and when you have no real-time synchronization requirements. So if you do have tables like that, or you don't really have any real-time synchronization requirements, again, snapshot replication may be a good fit. It's a poor use case for other replication types. Transactional replication, again, as I mentioned previously, transactional replication is great when you're replicating a transaction and you want to have those transactional confines respected on both your publisher and your subscriber. It uses a store and forward mechanism. Basically, changes occurring on your publisher are caught, they're trapped, and then they're stored in a distribution database. And from there, they're distributed to all the subscribers, to one or more subscribers. And this is done in a synchronous method. So I make a change. At some point in time later, the log reader agent, which captures the changes, is going to pick it up, is going to create these commands used to rebuild, reconstruct that command on the subscriber. And after the commands are read from the transaction log, markers are placed at the head of the log saying, I've read this transaction. So I've read this log sequence number. The log sequence number maps to the exact sequence in Profiler and exact _ seq no in MS REPL transactions. So you can look at this and track back what is going on in your log. And it's also useful for doing things like initializing from a backup or initializing from an LSN. So when I want to, if I have a very large database and I want to create a replication topology from it, I may want to back up that database, send it to my subscriber, restore it there, and then create my subscription. And when I do that, I have to ensure that the changes which are in that backup, the log sequence number in that backup, is also in my distribution database. And if it is, then I can backfill all those changes because I have a complete record in my distribution database to get my my subscriber database synchronized with my publisher database. So if I do a backup on my publisher database and my log sequence number is 1, let's say, and then all the changes occur, all sorts of changes occur in my publisher database, and now, right now, my publisher database has a log sequence number of 1,000,000. I restore my database on my subscriber. My log sequence number there is 1. When I set up my subscription, I say use this initialize from the backup. It reads that LSN there, which is 1. It goes to the distribution database and say, hey, give me all the transactions which have occurred after the log sequence number of 1. And so it downloads all the log sequence number transactions, the exact sequence number from 1 to 1,000,000, and then it gets everything in sync. Now, again, as mentioned previously, transactional boundaries are respected when applying commands on the subscriber. This means that if I update 20 rows on the publisher, I also update 20 rows on the subscriber. And what it does is it breaks down those transactions. So if I do update table name where PK is less than 20, what it does is it will generate 20 update statements. Update table name where PK is 0, where PK is 1, where PK is 2. So a 20-row update or 20-row insert is, which can be a single statement, is reconstructed as 20 individual update and insert statements on the subscriber. And it counts, did this row go in? Was this row inserted? Was this row updated? And if one row was affected, it knows that row made it, and I have at least that row on my subscriber. And then it counts the number of rows in the transaction, and it sees, aha, 20 rows on the publisher, 20 rows on the subscriber. We're good. This transaction was successfully replicated. Let's move on to the next transaction. Now, if I do a begin tran on my publisher, update table 1, update table 2, again, when I replicate this to my subscribers, assuming table 1 and table 2 are both published, what it will do is it will break down my updates on table 1 into however many rows are affected, updates in table 2 into however many rows are affected, and apply that within a transactional confine on my publisher, on my subscriber. And if that fails, it says, oh, my transaction was not successfully replicated. My agent's going to fail, and hopefully you as the DBA will know it, or you'll get an alert saying, I have a failure, let's go and fix this. And this is the way Microsoft intends for you to ensure that both your publisher and your subscriber are completely synchronized. So the data is the same on both your publisher and your subscriber. One thing to keep in mind here is one thing that follows from this is that if you do large batches take some time to process by the replication process. All right, demo. So let's have a quick demo here. Julie, can we see the Management Studio? Okay, I'm assuming
not
we
yet.
can.
Yes, now I can.
Okay, great. So what I'm going to do here is I am going to go on what I call byte inode A, and I'm going to enter some data. I'm entering CCC. Here we go. And I see CCC is there. And now I'm going to go to node B, and I see CCC is here. I'm going to put another C here, and I go right to here. Not there, not there, oh, not there. There we go. See, it just came in right now. So what we had was we saw that that took several seconds to arrive, and what I can do is I can go here in Replication Monitor, and I get to Replication Monitor by going like this. Drill down the replication folder, drill down on local publications, right-click, launch replication folder. I bring it up. Here I go. And what I can do is I can get an idea of how long it takes to replicate data by inserting a tracer token. So we're seeing this portion here from publisher distributors, my log read agent, how long it's taking. It's taking a little while. let me hop over to here. And again, plug it in here because this one I think is faster. Maybe not. Ah, there we go. So it took 4 seconds. 4 seconds for the login read agent to pick it up, and then 0 seconds to go to the subscriber. Let's go back and look at this guy. So we can see that my latency here is 1 second. It's 3 seconds to go to my subscriber. So what I hope you can see is I'm putting some data in here. It's going to node A. I go to node B. I'm looking for it here, looking for test to show up. And there, it just showed up there. Now, we notice that my primary keys are a little funky here. What I have here is on my publisher for BiDi node A, this is bidirectional replication. What I've done is I've set my identity value to 1 and 2. So my seed is 1 and my increment is 2. And here on BiDi node B, my increment is my seed is 2 and my increment is 2. So what I'm doing is odd values always occur on node A and even values always occur on node B. And this way I know that I will never have any primary key collisions occurring between the two. Now let's put something unique in here. I'll put 222. Now let's watch those guys come. So I see 111 and 222. 222 has already gone from node B to both node A and node B. And I'm looking for 111. There's 111. So 111 has traveled to both of my nodes. So this is a somewhat special form of replication. Not really well documented, but it is supported by Microsoft. And what you need to do is you need to add a special parameter called loopback detection to SP add subscription to get this to work. So you say add loopback detection, you set that to true. And it will prevent these nodes from looping back. So a change originating node A will be written to node B, but then it won't be picked up again and loop back to node A. Now, let's suppose I had something here where I had a node C. Let's think about this for a second. So what would happen is change originating node A would go to node B. And then loopback detection would say don't send it back to node A. But the change on node B would go to node C if this is part of a tri-node setup for bidirectional transactional replication. So change originating node B would say, I don't send it to node A, but I send it to node C. So it would go to node C. A change of node A goes to node B and C, so it goes from A to C. So what happens is it's going to go from A to B to C, and then from B to C. So suddenly we have 3 writes, and it's already on node C because it used the path from node A to node C. So we have a redundant write going on here from B to C. And this would cause my distribution agent to fail because it would be a conflict and I have to go in there and fix it. So the simple brainless way of fixing that would be to drill down on my subscriber and say, to use something called a profile, and I would want to use the profile called Continuing Data Consistency Error Profile. So the whole goal of transactional replication is to have both your publisher and your subscriber consistent, and it tries to protect that by anytime you make a change on the publisher which can't make it to the subscriber, the agent will fail until you can go in and fix it, and to ensure that transactional replication guarantees that both sides have the same data. Both sides are consistent. But what you can do is you can use the switch to continue in data consistency errors, which means that if, for whatever reason, it can't make that change, it will just skip it and continue. Again, this is not always a good thing to do, and it's probably a bad thing to do if you're using, or if you're in a financial sector. Okay, so let's go back to our slides real fast. Transactional replication. We'll be covering peer-to-peer in greater depth in a moment, because peer-to-peer builds on the metaphors of bidirectional transactional replication. A couple things I want to point out about transactional replication is what you can do is you can replicate the execution of a stored procedure. So if I have a process where I need to update 10,000 rows, it's going to take replication quite some time to replicate that 10,000 row update on your subscriber. It's going to make that change, and then it's going to see, did it affect a row? If it did, good, let's do the next one. And it has to count all those and put that in a transaction. And if you have a user activity on the subscriber, it may be blocked by that large transaction. So what you can do is you can wrap that 1,000 row update statement in a stored procedure, and then replicate the execution of that stored procedure. And if you were able to look into the distribution database to see what the command is, you would see execute, or exec, my proc. That is what replication has done, and it will execute that on the other side. And there's a way, actually, of peeking into the distribution database called SP Browse REPL Commands, or SP Browse REPL CMDS, that will allow you to look at what is in your distribution database. Now, if you're going to replicate the execution of a stored procedure, what you may want to do is you may want to make it serializable. There's two options. There's three options. I can execute the replication of a stored procedure. I can execute the execution of a stored procedure serializable, or not serializable. And what serializable means is that if I have a transaction which looks like this: begin tran 1, execute proc 1, begin tran 2, execute proc 2. Here we'll notice that tran 2 is committed before tran 1. If I use a serializable option, what this will mean is it will respect this whole thing as a serializable unit. It will execute proc 1, then will execute proc 2. So if I was able to peek into my distribution database, what I would see is I would see the command proc 1, then proc 2. Now, if I didn't choose to execute the stored procedure replication in serializable mode, what would happen is I would see execute proc 2, because that is committed before proc 1, and then I would see execute proc 1. All right, let's go back to our slides. Julia, are we getting any questions?
No questions at this time.
Okay, good. All right, so here. Okay, great. Updatable subscribers, again, deprecated in 2012. There were two modes of this. One where you use a link server and MS-DTC, the other queued. What would happen is if my link between my publisher and my subscriber was severed for any reason, changes occurring on my subscriber would be executed using a link server, and it'd be controlled by MS-DTC. And if my publisher link was down, these triggers would fail, and that table in my database would be read-only. So Microsoft also had a queued option in there, so I could fail over from immediate to queued. And queued would use a queue reader, and it would store the changes in a queue, which would be read and replayed on my publisher. And you may see this quite a bit because it's a long-standing bug. When I script something out, even if I'm not using queued replication, what it will do is it will add a statement, adding a queue reader to your publication. Okay, again, we've talked about this. And basically, it's not advised to use this because not a lot of people use it, smaller user base, a lot of unknowns with it. Bidirectional transaxle replication, we kind of talked about this, so it doesn't require a GUID key to uniquely identify each row. Merge replication does. The publisher is also a subscriber, so I take node 1, I make that a publisher, I replicate to node 2. I make node 2 my subscriber, then I turn around and make node 2 my subscriber and publish back to node 1. Again, I use loopback detection. It's faster than merge replication and faster than peer-to-peer. So if you are using peer-to-peer today between two nodes and you need faster replication or lower latency, you may want to think about using peer-to-peer. Bidirectional transaxle replication is ideal for scaling readouts. So this is when all my changes are occurring on one node, and I can have another node where all my reads are directed to. Demo, we've kind of already looked at that. Okay, one of the caveats with bidirectional transaxle replication is that if I update the same row on node A and the same row on node B. Let's suppose on node A I have a person table and I update someone's last name from Jones to Smith, and on node B I update it from Jones to Smith with an E-S-M-I-T-H-E. What will happen is Smith on node A will go to node B and it will persist Smith there, no E. But at the same time, Smith with E is traveling from node B to node A. And so Smith with E, S-M-I-T-H-E, will persist on node A. So you've swapped your data perfectly, and no complaints from replication. Replication thinks everything's fine. The thing about bidirectional transaction replication is identity seeding is difficult. So if I have a database which has been in use for, let's say, a couple of years, and then I want to take that database and add it to another server and configure bidirectional transaction replication, I can't easily take those existing identity tables and change the increment from whatever it is to 2. So what you will probably need to do is you have to run check-ident and pick one node and bump up its identity value, its increment, its current identity value to maybe 1 million. So now node B, all the identity ranges assigned are going to be 1 million, 1 million, 1, 2, 3. Whereas on node A, they could be at 50,000, 50,001. So you now have 2 islands of identity ranges, which at some point in time will collide, but you do have considerable time before node A starts to hand out identity ranges in over 1 million. One thing about bidirectional transaxle replication I want to mention is that if your nodes are disconnected for any point in time, the greater your chances of having a conflict are, or duplicate data. And what a conflict is I change data on both sides, or I insert the same primary key value on different sides, or I update a row on one side, I delete it on the other. So those will all create what we call a conflict, which basically is some data anomaly which is irregular, which Microsoft thinks you should look at. Okay, peer-to-peer. So peer-to-peer is an enterprise edition feature only. It is bidirectional. It uses a mesh topology. For all of the replication types, if your publisher goes down, data is going to sit on your subscriber or on multiple subscribers, and it's going to stay there until the publisher comes back again. With peer-to-peer, there's multiple routes. So if I have 3 nodes, node A can talk to node B, and node B can talk to node C, and node C can talk to node A. If node A goes offline, node B and C can talk to each other and exchange data until node A comes back again. This is what a mesh is. And SQL 2008 and above have conflict detection. Now, there's no real conflict resolution. I have to kind of qualify what I mean by this. With the conflicts which occur in peer-to-peer, you will assign a peer-to-peer node with an originator ID value. And I can make one publisher have an originator ID of 1, another 2, another, let's say, 6. The lower the value of my originator ID, that one originator will have its changes persist over other changes. So if 2 changes occur, originator ID of one change is 1, originator of another ID is 2, the change from 1 will be the one that will persist throughout your topology. It is a smaller feature set than transactional replication. For example, it doesn't support identity ranges well. No custom store procedures, no custom replication store procedures. There's other things as well. But those are the major 2 problems with peer-to-peer, the reduced feature set of peer-to-peer. Let's have a quick demo of this. So I have something set up here. Okay, so basically what I'm doing here is I am creating peer-to-peer from scratch, dropping my database, and then I'm adding it. What I'm doing here is I'm saying the publisher wins, originating from backup. I am enabling peer-to-peer. I'm saying I want to do conflict detection. This is my originator ID. I'm going to continue on conflict detection. Otherwise, what would happen is my agents would just fail. I have to go in, fix the change, and go from there. So what I've already done is I've already created my peer-to-peer topology. We can create it from scratch in a moment. And I've already created a conflict. So we'll look here, and I see I have a conflict. I can, if I have multiple publications, I could drop them down here. Multiple databases. Again, I could drill down on a particular database on a particular publication, and if I had multiple tables, I could see the conflicts there. So here's my 2 conflicts. This is insert conflict. So I inserted one value here on the publisher and the subscriber, and here I have a second one which occurred. Now, these are the same identity key values. So that's one of the reasons why I have this here. And I can choose to remove this if I want. And now my conflict will no longer show up in the conflict viewer. Okay, remember I selected here, for this I selected that we were going to continue on, I'm going to detect my conflict, which means it's going to show up here. And then what I said was, whoop, I guess I blew that away. And then I said continue on continue when I have a conflict. Don't let the agents fail. So I can go and I can create these 2 publications. I'm not going to do that. What I want to do is I want to go here and I want to add some data. So this, I have 2 different instances here, SQL 2014A, and then I have my default instance. And what I'm going to do is I'm going to put a value in here, and I call this, let's say, okay, A. So I go over here. And there I see A and B. Okay. There's B. I think, okay. Actually, we're having a conflict here, and I made that change. I see C here. This is in my default instance. I go over here, so I want to see C and A. I go Okay. So C is what I want to see. C isn't making it because it's been logged as a conflict. And I will see it here in my conflict viewer. There it is. A and Z, A and Z. Okay, I just want to verify this again. Let's put in the letter H. And I want this is instance H, and let's put in the letter Q. Now I want to see these guys. H, and I don't think. Okay, so my conflicts are all here. I don't see where Q is yet. May not have made it. But we are seeing a conflict. That conflict is caused because I chose, when I created this, I chose to use the identity value. Here's my table. Oh, this is node B setup, and I want to look at node A because I restored that from backup. So here's my table. I have the identity value on that. So what I'm going to do is go here. Okay, and now I should be good. Let me put this guy in here. Go back. And let's pick P. So Q and P. See, now Q and P are making it. All right. So by reseeding, I was able to get both these guys to work. All right. Now, so that's peer-to-peer. Let's talk about merge replication here. So merge replication is designed for cases where you have a large number of branch offices and you want them to send their data to a head office. And occasionally this data, this head office may want to send data down to the stores. So it's designed so that the majority of the changes can occur in a branch office, multiple branch offices, or on the publisher itself. It's ideal for point-of-sale applications or for where you have salesmen in the field. It uses this tracking column, this row-grid column, this unique identifier column to uniquely identify rows across a replication topology. And it uses tracking triggers to do the change detection. Basically, when you think about merge replication, think about how you would react if you see a friend that you haven't seen for quite some time. Basically what you do is you would say, when was the last time we saw each other? And then when you establish this point in time, maybe 3 years ago or something like that, then you would say, what has happened since that last time you guys spoke or communicated? Merge replication works the same way. When the merge agent talks to the subscriber, it says, when was the last time I spoke to you? And this is in the merge replication nomenclature, this is called a generation. So what it does is it says, oh, last time I spoke to you, you were at this generation. And then what it does is it uploads all the changes which occurred since it last occurred. This is the publisher talk with the subscriber, and it brings all those changes up to the publisher, and then it tries to apply them on the publisher, and then it brings the publisher changes down to the subscriber. And what it will do is it will bring all those changes up, and it will see have any changes occurred on the publisher for that row. And if it has, we call this a conflict. Okay. Okay. So let's actually have conflicts are either errors or changes to the same row or column which have changed on both sides. There's a conflict priority. There's two ways of setting up your merge replication topology: server, which is also called global, or client local. What server does is it says that the publisher is basically the winner. And what a client does is it says that when the client makes changes, these changes are going to persist throughout the topology. If I have 5 users, 5 subscribers, subscriber 1 gets into the publisher first, its change is going to persist throughout the entire merge topology. Subscriber 2 goes into sync. It also had made a change the same row that subscriber 1 did, but subscriber 1 got there first. So subscriber 1 change will overwrite subscriber 2 changes. With server, what I can do is I can set different policies or different weights on different subscribers. So one subscriber might have a higher priority than another subscriber. So subscriber 1 will win over subscriber 2. It's not who made it there first. So if I have a priority of 90, a change occurs on subscriber 1 with a priority of 90, it will go to the publisher. Its change will persist there. Then another subscriber with a priority of 95 will come in. It will wipe out subscriber 1's change. It will replace it with its own, and then it will go back to subscriber 1 and make subscriber 1 the same value as what subscriber 2 did. In every case, changes occurring on the publisher will win for both server and client. Okay. Merge replication also allows web synchronization, and what happens is a lot of subscribers a lot of clients, a lot of people want to be able to replicate securely. So merge replication allows web synchronization over HTTPS, and this allows clients in the field to connect over port 80 or port 443 and communicate with the publisher and synchronize their data and download data that way in a secure fashion. We can also do very rich filtering, so I can filter the data which goes down to a particular subscriber. I can filter it vertically, which means only certain columns, or horizontally, which means that only some data which matches a certain subscriber will go down. And I can also change it so that I can configure it so that if I make a change to a parent row, that all the related child rows will also be in motion. We call this a partition. For example, if I have a salesman, and a salesman has a territory of, let's say, the Northeast, and this salesman then is transferred to, let's say, the Southwest, what I can do is I can change his territory in the database, and now all of his child roles will now go to someone else because he's no longer the Northeast, he's the Southwest. So I'm changing from the Southwest. All his Northeast data will leave his database. It will either be deleted from his database, or I can configure it optionally to stay there. But he'll get a new set of data which applies, a new set of child data which applies to the Southwest. And we call this partition. This is what we call pre-computed partitions, which means when I'm changing my data, that changes are stored in tracking tables. So when the subscriber connects, it will go to this tracking table, and the tracking table will say, your subscriber X, you get all this data, and it will send it down to it instead of having to enumerate it. Okay, so let's have a quick look at that. I have a bit of a video of this, so let's have a quick look. Here, I'm looking at a particular client of mine, and I want to talk about this for a second. So basically, this is a large distributor in New Jersey, and what they're doing is they're sending data down to a lot of subscribers. I think there's 10 subscribers there, and each subscriber gets all of the data. We could filter it so that they only get their data, and each subscriber here represents a store. Now, what is interesting here is that a store can sell another store's merchandise, and this merchandise would be delivered to the customer. So a customer goes into, let's say, goes into New York, orders some data, or orders a product. And let's suppose there's 1,000 units of this product, and they buy 800 units of this product. So there's 200 units left. So what the value of that product, the inventory of that product, should be 200. Now, someone else goes to a different location. Let's suppose they go to the Philadelphia location, and they buy 500 units. And now there's 500 units left in their inventory. Now, when they go to synchronize, we have an interesting problem. We had 1,000 units, one place sold 800, another place sold 500. So when you add the total sales together, they should have sold 1,300 units. But when we synchronize, what's going to happen is we're going to have a conflict, because the same inventory for the same product has been changed. One place it's changed down to 200. The other place it's changed down to 500. When we synchronize, what value is going to persist? Well, maybe 200, maybe 500. Both of those values are wrong. The real value should be negative 300. So what we can do here is we can do something, and what I've done is here. We'll see it in a second. So I'm looking at the properties of this particular article. I'm going to stop it. Okay. And what we're doing is we have a stored procedure resolver in there. So what this stored procedure resolver does is it goes out and it does a little bit of math, and it figures out, well, what should the inventory be? And actually it's doing something a little bit more complicated there, but it's doing something. We could use that to hijack it. And then I have another one, and this one is using a .NET class, and I have something called a business logic resolver there, and it's running a .NET class that does some processing to figure out exactly what we're going to do here. Basically, just to explain what is going on here, is this is part of an ERP system, and what it has to do is, if certain changes occur, certain changes will flag certain changes. So if I make a certain change, it has to evaluate that change to see, is this change coming from the ERP system or from the store? If it's coming from the ERP system, do I have to do something special to change some of the store data in a different table? So that's basically what it's doing there. But one of the things I want to point out to you is that what we actually do here is, when I sell things at a store, it does come back as 500 or 200. It does come back. And then what I do is I have a trigger which goes out and it looks at the sales orders, and it says, oh, look, this unit, this product was sold both here and here. Its location in point A in New York City, its inventory in New York City was decremented to 200. Its inventory in Philadelphia was decremented to 500. So I'm going to do some math, and I'm going to figure out that the math for the total sales for that particular product will deplete my product to negative 300. And it does go in and it makes that change. And what happens is, replication says that changes occurring via triggers kicked off by the replication process are not flagged to be replicated again, because replication is making that change. And so it will persist. So let's watch. So I think that's basically what I wanted to point out in that video. Okay, so we're done. Let's go back to the presentation.
So,
Okay,
Hillary,
so
we're right at
yes,
2 o'clock. I didn't know if we
right.
can wrap up or ask some questions or
Yep. Are there
how.
any questions?
We have quite a few. I just didn't know how close you were to the end.
Well, if the answers appear in, I think I have like 5 more slides. Let's see. Right now we're on 25, so 7 more slides. Why don't I take the questions first, and if the material in the rest of the slides addresses those questions, we will. I'll just leave to those slides.
Okay, so I don't know if you already covered these. Is there any script to check the number of transactions commands pending to be sent to the distributor from the publisher?
No, no, there's nothing because the log is kind of a black box. No. Chris Gorminski in RepleTalk, it's an MSDN blog, I believe he does have something which allows you to use function dblog, I believe, and you can kind of peek into the transaction log, but it's expensive. So short answer is no, I don't believe there is.
If you have 2 to 3 nodes, then would you recommend bidirectional over merge?
If I have 2 nodes, I would probably use bidirectional. Merge replication is slower, but it's as a much richer feature set, especially for conflict. So I would look at the use case. If performance is critical, I would go with bidirectional transactional replication, knowing that data could be disposable. The problem with bidirectional transactional replication is it's so fast. If it goes down at any time, you want to leap in there, you want to be really proactive and get things up again to reduce the chances of duplicate data. With most bidirectional transactional replication topologies, what happens is if it goes down, people see, oh, where's my data? And they say, well, probably didn't get entered, so they enter it again. And they may do it several times. And then you have to deal with accumulated duplicate data which has occurred because your agents were down. Next question.
So for SQL 2012 and forward, you would recommend using P2P replication when replicating between multiple nodes instead of bidirectional replication or trans with updatable sub-switch, which is deprecated. Why the Enterprise Edition?
So you really don't want to use updatable subscriptions anymore. You can still use them in 2012, but they're really only good for when the majority of the changes happen on the publisher, and a few times they seldom happen on the subscriber. Merge replication is a much better fit for that. You can scale out merge replication the same way that you can scale out updatable subscriptions. Updatable subscriptions is only good for, let's say, 4 to 10 nodes. So it's being deprecated for a reason, and it's being deprecated because it's basically difficult to use. So basically, peer-to-peer is good. It's the Enterprise Edition. A lot of people balk at the cost of the Enterprise Edition. I have a customer who is shelling out $250,000 for licensing for their SQL Server, and when you deal with these with costs as prohibitive as that, you want to take a long look at Standard Edition. And so if you want to do any form of data distribution or data aggregation, replication is a good fit for that. If you have more than 2 nodes, you have to look at merge. Merge replication is slow. it will slow down your entire workload. So then you have to do a cost trade-off. Do I want to use merge replication? Do I want to go to the enterprise edition? If it's 2 nodes, bidirectional transaction is a good fit.
Okay, and how do you manipulate the agent parameters to fix the replication latency? And what are those parameters?
Okay, so we're kind of going into that here. So for performance tuning, there's some switches that you can use, command line switches that you can put on your agent. Here are some kind of tests which I've done. So if I do, this is a log reader agent one, so if I do a 10,000 single inserts, I find that for history of verbose level 0, I think that's the color right here, that that my worker time, I believe that's worker time. Let me just hop here for a second. Yeah, this is in seconds. So this is history verbose level and output verbose level. History verbose level are those. This is my worker time. For a setting of 2, for my output verbose level, it takes a long time. For one I get the shortest time to distribute 100 transactions of 100 singletons. So we're looking at 60. That's probably 60. This is probably 600 it's probably 600 seconds. So here it takes 1,000 seconds for a 10,000 singleton insert. Here's also the effective worker time for commit batch size. This is distribution agent settings. So what happens here is if I set my distribution, my commit batch size to 10,000, and so it's this one here, and my commit batch threshold to 10,000, I see that my worker time is about maybe 3,000 seconds, 3,000 milliseconds, yeah. And here it's maybe 1,000 milliseconds. So if you play around with these settings, you can dramatically reduce the distribution time, the amount of time, you can dramatically reduce your latency, but you have to make sure that you match these with your overall workload. So this is on a single table. You may have some tables which have very small numbers of inserts. So it's singleton transactions the whole way. And then I may have other tables where I do batches of maybe 100 inserts at a time. So what you want to do is you want to query MS-REPL commands and aggregate it by your article ID, and then you can get a really good idea, well, these are my really big tables. These are my tables which are generating all my replication activity. You want to pull them out, put them in a separate publication, and then you can tune them for commit batch sizes, commit batch threshold, which work best for those particular workloads on those tables. You also want to look very carefully at how my changes are coming to my system. If they're coming to my system, I may be able to encapsulate those changes in a stored procedure and then execute the replication of that stored procedure. For example, if I frequently update 10,000 rows or 100,000 rows, I can wrap that in a stored procedure and execute on the publisher, execute on the subscriber. Just make sure that the data dependencies on both sides are identical. For example, if my stored procedure references a table called blah, I have to make sure blah is on the other side. I have to make sure that blah has that same table on the publisher and the subscriber. Another interesting thing is I can execute a stored procedure on my publisher. It's going to execute on my subscriber, but on my subscriber, it can do something completely different. So it really depends on what you do. So just to get back to rehash for performance tuning methodologies for replication. Look at your publication, try to break it up by data dependencies, and also group them according to volume of replication activity. Put them in a separate publication. Use the independent agent parameter. And then you can have multiple streams going into your subscriber where one agent is not throttling another agent. Then you want to use commit batch size, commit batch threshold to see if you can push more data to your subscriber per second than you would with the default settings. So those are kind of things to look at. I just want to back up for 1 second. The first thing you should do is look at your subscriber, see what your subscriber is waiting on. Is it waiting on disk? Is it waiting on CPU? And address that problem. And once you address that problem, then you can start fiddling with these switches to optimize your performance. Next question.
How do you change the schedule on an existing subscription and an existing publication?
So what I have here, so in Replication Monitor, I can drill down on the agent properties. Let's just have a quick look here. Distribution agent properties. I can go here, schedule, and I can set a schedule. This one here starts automatically. Starts whenever SQL Server starts. So what I can do is recurring, and I can set up something there. But so I can set whatever schedule I want there. But what I have to do is I have to drill down on the agent. And just wait for this to come up. And I see at the end there's something called continuous. What continuous means is that what the agent will do is it will read the distribution database. And then what it will do is it will read for a predefined time period. So it's going to read all the slug of data which it sees it can. And then it will go to sleep for what they call a polling interval, whatever is set in the polling interval. The polling interval by default for the distribution agent is 10 seconds. And then after 10 seconds, it will wake up again and it will consult the distribution database and say, what else do you have for me to replicate? So by default, your schedules are continuous. They start whenever SQL Server agent starts. You can drill down on the job itself and you can assign a schedule to it. And that's a very good thing to do because what can happen is your agent may fail and it may eventually shut down. And so you may want to schedule it so it's going to restart at some point in time. Now, if I have it fail, so if it fail, basically if I have it on a schedule, I can wipe out that continuous, and then after it reads the batch of data to replicate, it will go to sleep until the schedule picks it up again. And sometimes you want to do this because you don't want to constantly, if you have a relatively trivial or bursty workload, you may not want your agents to run all the time. It may cause contention on your system. So you may want your agents to read all the data to be replicated, apply it, go to sleep for 5 minutes, wake up again, read the new data waiting for it, distribute it, and then go back to sleep. So that's basically how you would go about scheduling your agents. On the subscriber, you would, again, I would drill down through my local subscriptions folder, and I don't think I have any here. They're going to look very pale. If they were a dark color, that means that they're scheduled on the scheduler, on the subscriber, and I can drill down and assign a schedule to them. Any other questions?
Just a couple more from Sandra that I can send to you. Are you finished with the presentation slide deck, or should we?
Yeah.
Okay. Oh, okay.
Basically, yeah.
Okay, so It's what's the best, well, I guess if you could put your opening slide that has your blog or
Sure.
your address on, what's the best replication choice for high volume transaction database being sent to a data warehouse that needs almost real-time synchronization? And which is the best replication when encountering primary key duplication violation issues when not at liberty to set the primary key sequencing?
All right. So if you're replicating to a data warehouse and you have really low latency requirements, you may want to look at Service Broker. Service Broker is a bit of a black box. It can be used to replicate volumes of data to a single, or you can configure it to multiple subscribers, but to a single subscriber, it's a really good fit. There's no nice wizard or interface into peering into the internals of Service Broker, so it's difficult to use, but it may deliver the latency you're looking for. With transactional replication, I can replicate to a table with a completely different configuration. Now, whenever you're processing large volumes of data, you struggle no matter how you're doing it. You're going to struggle in Service Broker. You're going to struggle in transactional replication. You're going to struggle in SSIS. SSIS doesn't really have the well, actually, with change tracking, you can configure change tracking with integration services to run it incrementally. So you may be able to get very low latencies with integration services. It's not really my sweet spot. But it's difficult to move large slugs of data, no matter how you're doing it. Replication is a good canned interface for doing it. I guess I would look at where your sweet spot is. I would try replication. I would probably try a Service Broker and see what works out best. Someone who's good at SSIS might try SSIS. They may have better success than I would. I simply don't know. The second question, though, can you repeat the second question? It's about identity values.
Replicate high volume. Which is the best replication when encountering primary key duplication violation issues when not at liberty to set the primary key sequencing?
What happens is you can use custom stored procedures, and these custom stored procedures will replace the default replication stored procedure. And what they can do is they can do an existence check to see if that value exists on the subscriber. If it does exist on the subscriber, it can throw away the change. It can write to another table. It can perhaps, I guess you could probably run set identity insert on that table. It's not a good solution. One of the things, if I have identity values on my subscriber, I can set the identity value to use the not for replication attribute. That means when SQL Server Replication is trying to do that insert, it will not enforce that replication property on the subscriber. I'm trying to push identity value of 10 into a table. The identity value currently in use in that table is 20,000. 10 will slide in if 10 does not exist on that subscriber. If it does, there's a collision, and you can do things. You can wipe out that value. You can replace it. You can change that insert into an update. You can write to a different table for later resolution. It depends on what you're trying to do. There's no good way of merging two identity values. I have 10 on the subscriber. I'm trying to push 10 in. Unless you have some rule for what to do, you're kind of stuck. Another question?
I'm checking. This webinar is being recorded and it will be posted to the DBA Virtual Chapters archive page. When you restore replicated database from production to staging, do you have to regenerate the replication?
No, but there's complications with that. The first complication is that I have to have replication installed on the server I'm replicating it to. Then what I have to do is, when I do my restore, I have to restore with the keep replication switch. What that will do is it will preserve the replication metadata. And what that means is that the replication objects, like let's say sys articles, sys merge articles, those tables will be restored. And that database will be restored as a replicated database. So all the objects, all the metadata will be there, all the system objects will be there, the replication triggers will be there, the GUIDs will be there. If I don't use that replication switch, they will be removed. So if I'm restoring to a dev and for whatever reason, I want to keep the replication settings, they will be restored with the keep replication switch, but I don't have the agent information, which is in the MSDB and the distribution database, so I don't have that information. So there's not a lot I can really do with that, the replication settings in that restored database. If I want to take that database in a replicated environment, restore to dev environment in the replicated environment, and I want to be able to, for whatever reason, have replication installed and running, I would need to restore the master, the MSDB, and the distribution database with the keep replication switch. And then I would have to ensure that the server name is identical. So there are ways of doing that, but not normally dev. For DR purposes, yes, keep replication switch and restoring that master MSDB distribution database, it can be done. There will be some data loss. But I just don't understand why you really want to do that in dev. I guess I would ask what the goal is.
Okay. I did want to mention that Clive Allen at DELCOMO at Outlook.com is the winner of the $50 Amazon gift card, which is supplied to us from Dell, since they are our sponsor. So Clive, you're the winner for today. There's just, I guess, Hillary, would you be able to send me the slide deck so I could also post that
Sure.
to our website? Okay, so I'll be posting that later today, and then we'll try to get that recording up as soon as possible. If you want to stick around, we have just a couple more questions. What is the solution to get for the publisher to get refreshed every alternate day? Do we have an option to stop and start or alter restore on the publisher database?
If I can set up my agents to run at whatever interval makes sense to me. So I could set up my agents to run every day or every second day. I would like is ideally I have my log read agent running, so the size of my publication database would be maintained. Now, I heard the word restored in there, so if I want to restore the publication database into dev, you know, you can use log shipping for that, and then when you want to restore, during the final log restore, you would select the keep replication switch. And as long as the distribution database is in place, replication is installed on the destination server, it will come up with the replication settings preserved. If you're trying to do something like capture changes on my publisher and replay them in the dev environment, you know, a differential backup or or log shipping is probably the best way to get the data over. Again, I'm a little confused about what the goal is and what you're trying to achieve.
Yeah, it's I think if the publisher gets refreshed every alternate day, do we
Okay.
have an option to stop and start?
Yeah, actually, there's SP start. I use that here. Right? Let me just pull it up. Here, I'm stopping my subscription agent, so I can use that, and I can use start. So let's just run this real fast. I stop my agent and start. I just whoop. So I can use those guys if I want to. Darn it! Start subscription agent. It's something like that. I can't quite start. Maybe it's this. I can't remember. There's a something very similar to that, and but you could in the scheduler. There's rich settings in the scheduler. I can do things like this. I can just pull a job up. In my schedules, I can do things like occurs every daily, occurs every 2 days. I could do that. I can do things like monthly, every, whatever you really want, you can configure. I could do every, like I have days, no, I don't have days there, but 24, maybe that'll work. But there's lots of settings that you can use in your schedule to have it run every second day.
It looks like someone else is chiming in that they refresh the replicated database sometimes. Let's see. When they refresh the replicated database, sometimes the replication breaks, and then the next one, which is related, but the log sequence will not match if I stop the agents right. Won't that cause the new data with a different LSN?
No. So refresh. I'm struggling with what this person means by the term refresh. Refresh to me can mean I restore, or it can mean that I have a batch of data from BCP and I'm going to push it into my database. So replication should be able to handle large slugs of data. If you have huge slugs of data.
Restore is what he's meaning.
Okay, so with restore, with restore, so I have an existing publication in place, replications in place. I restore a database from I don't know when, I don't know where, but I would look at SP REPL restart. And what that does is it says, okay, my LSN in my distribution database does not match or come close to an LSN in the transaction log of my current database. Let's just skip that and let's start with whatever LSN I have in my publication database and start reading from there. So SP REPL restart will do that. So that is probably your option. What I don't understand though is I have a database, I'm restoring it. Where'd that database come from? Is it old? If it's old, SPREP restarts the way to go. If it's from a different server, you may be able to get it to work on that server, on server you're starting to.
He says that you've answered his questions, so he's gonna try that. Hillary, I want to thank you for going over today with the presentation, but also answering the questions. I will send you a list of the questions that were asked, and if you could just email me the slide deck, I'll get that posted to our archive page on our website. I want to thank everybody again for joining the DBA Virtual Chapter lecture today, and we'll have another one in a couple of weeks. Thanks again. Bye.